Welcome. I'm Teacher Michelle, and I'm here today to talk to you about how to use some tools to help you solve some problems. When we are talking about STEAM and thinking with STEAM, that's just a way to look at the world with science, technology, engineering, art, and math in mind. So that's using all that creativity and all that information, all that question asking to solve some problems. And we are really good at solving problems. One problem that I'm going to talk about today is finding out how much something weighs or which thing weighs more. So there are many reasons why we want to find out what something weighs. When we're at the grocery store, we want to find out if we have enough money to buy a certain amount of something. And so we put it on the scale at the grocery store to make sure we're only getting so much so we can pay for it. When you go to the doctor, you stand on a scale to find out how much you weigh to make sure that you are growing and are healthy. So we use a tool called a scale for many, many reasons. So this is one measuring tool to measure weight. And I just wanted to remind you that we've been using measuring tools all along. We use a ruler to measure how long something is. So that's a measuring tool. This year, we've also made rain gauges to measure how much rainfall. So tools help us measure, and measuring is important for solving problems. So today, I brought this kind of a scale, and I'm going to write that word just so we can see it. Scale. Can you hear what sound it starts with? What letter and sound? Scale. I'm going to write it really big. Can you see it? Yes, it's an S. Scale. This is a particular kind of a scale. It's called a balance scale. Can you say that? Balance scale. So these two items, I'm going to show you something. This tool moves. So it is set up. Put it on this so you can see it better. It is set up on here so that allows it to have things in this container. And you can put something in here to compare it to over there to see whether they balance or which weighs more. So you notice if I put something on this side or if I put pressure or weight on this side, it moves. Now, when you don't put anything in it, I'm going to hold still so you can see it really well. If I don't put anything in either one of those containers, it stays right in the middle. And when it's right in the middle, that means it's the same. They're balanced. The air in this, nothing, there's just air in there. And the air in this side, nothing, there's just air in there. They weigh the same. I know some people have used this before. Have you used something like this before? So this is a balance scale to compare things. When I was together with some friends, we talked about it, and they showed me that at their house, they have a special kind of scale that's not a balance scale. They have a scale like this. Do you have a scale like this at your house? If you do, how do you use it? Do you balance things on it? Do you compare things on it? My friends, when we were together, told me they put their feet on it. You put your feet on this, what are you trying to find out? You're measuring you. You're measuring how much you weigh. So I might give that to you as a challenge. If you have a scale at your house, stand on it and notice what happens right here, what numbers come up, and see how much you weigh. Okay, let's get back to balancing, shall we? So when you're balancing or finding how much something weighs or which weighs more, then you are going to compare two things usually. So I brought some items for us to compare. And I always like to try to trick you, make it a little bit more challenging. So I brought 2 apples. I brought 2 apples so we could compare and find out which weighs more. So let's describe what we see. So this apple looks like it's reddish yellow maybe. And this apple looks kind of dark red. So which weighs more? Do you think the golden red apple or the dark red apple weighs more? Now we're just making a prediction. We have no information other than we're doing 2 apples. We're just predicting, which means you're making a hypothesis. I think maybe you'll notice that this one looks a little bit bigger. So maybe you're going to say, I think this one, the reddish gold one, looks a little bigger. So I think it's going to weigh more. Maybe. And if we were together, I would hand these to you. And you would be able to use the tool of your hands and your own judgment to kind of go, one of them is heavier. If they're quite a bit heavier than each other, you can tell that. If they're very close, it's a little bit harder to tell. And that's why humans invented a tool called a balance scale to help them figure out which weighs more, because it's hard to tell. Okay, I'm going to put this one in first. Are you ready? I'm going to put on this side. What do you think is going to happen when I put it in the balance scale? Do you think it's going to move, or do you think it's going to stay balanced? Tell your grown-up. Whoa. I'm going to try that again. I'm going to wait for it to balance. See, it's right in the middle. It's balanced. Well, now it's off balance. And when it pushes it down like that, the weight is telling me that what's in this container, the apple, weighs more than what's in this container. Nothing. This apple weighs more than nothing. Okay, I'm going to add this apple now. You ready? Whoa. Boy, that didn't take long. Should I show you again? Whoa. Are they balanced? No, this one definitely went down and pushed the other one up. That means this one is heavier. Now let's talk about why. Oh, see, when I take it back out, now this is heavier than nothing again. Let's look at these two things. Now, it could be because it's a little bit bigger. It could be. Or it could be something else. And if we were together, you'd be able to figure out really easily what the difference in these 2 apples are. But because we're not together, I'm going to have to use my senses, and you have to use your senses a little bit more to figure it out. So just by looking at these 2 apples, we think they're pretty much the same. They're both apples, correct? Now, I want you to listen to something. Can you hear it? Whoa, that's a strange sounding apple. Let's try it again. Let's listen to this one. Do they sound the same? They don't sound the same. They sound different. They both have a stem. They both have the bottom. I took a piece out of this one to show you. This one is real. That's why I can cut it open and it sounds different. This one is not real. It's made out of plastic from our pretend kitchen. Do you think a real apple or a plastic apple weighs more? Well, we found out a real apple weighs more, at least in this experiment, than a plastic apple. This one weighs more. I'm going to put it over here. Should we do another one? What's this? Have you seen it before? Tell your grown-up. I'm listening to it, using my senses to figure out what it is. Oh my goodness, I have to show you this. Hold on. Can you see? Hold on, I'm going to show you. Hold on, let me find it. Can you see those? I was testing it. And look what came out. Well, I was going to ask if you thought it was real. Sorry for making you dizzy, but that was a moment. I was trying to see if you could see if it was real. And 3 little bugs came out. Do you think it was real? Yes, it's a real pine cone that I got out of my yard. And it was so real. Where'd they go? I want to make sure to take them and put them back outside. Here's another one. I'm gonna shake this one. So that one didn't have any in it. That was so interesting. You never know what's going to happen when you're using natural items from outside. Oh, there's another. Oh my goodness. Okay, hold on. Look what I found now. Can you see it on my computer? That was a little roly-poly bug. Okay. Whew. Well, that's science for you. When we're together, things like that happen all the time. But I really did not expect, because I've had these out of in front of my house for a long time. I did not expect that when I was testing them to see if they were real or not, if bugs would fall out, but they did. So that was kind of a wow surprise. Back to the experiment. So I have 1, 2, 3 real pine cones. And if you've ever picked up a real pine cone before, do you think they're heavy or light? Yeah, I don't think they're very heavy. I can lift them all by myself. So I'm going to compare them though to something else to see which weighs more. So I'm going to put 1, 2, 3 pine cones on my balance scale. And it definitely 3 pine cones weighs more than nothing. I can tell it weighs more than nothing. There's nothing in that. I have a bag of small pine cones. Do you see? Are there more than 3? Can you see more than 3? I see more than 3. We'll count them to find out how many more. So I'm going to compare whether 3 medium size or bigger pine cones weigh more than, and I'm just going to show you. They are different sizes, just so that you believe me. Use your own senses to notice that this one is a little bit bigger. So I'm going to put 3 pine cones in there. And let's see if it weighs more, the same, than 3 of those. Oh, 3 of these pine cones do not weigh the same as 3 of those. See if we can balance the scale. I'm going to add 1 more. Now it's 4. Oh, it moved a little bit. I'm trying to keep an eye on the bugs. So if I have to stop, I just don't want them crawling all over my house. Right now, they're just on this little table, but I don't want them crawling all over my house. Oh, I forgot how many we had. 1, 2, 3, 4, 5, 6, Ooh, are you noticing that the scale is moving? They're becoming closer in the same weight. 7. Oh, I'm going to just stop right there. See what happens. The scale is trying to gauge how much they weigh and which one weighs more. Oh, we're so close to balancing our scale. Do you notice? Here's the middle. When they're in the middle, it's balanced. So I don't want to add a big one because I'm afraid it would be too much more. I'm going to add this small one very carefully right here. Let's see. It's so close to balancing. But I forgot to remember how many I counted. 1, 2, I'm just going to have to count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 of this size pine cones, the smaller ones, is going to balance or weigh the same as, because when they weigh the same as, they're balanced, 3 of the bigger pine cones. I'm going to let that sit right there. So we use some natural items. Now, I thought I would try to use 2 different forms of matter. So, can you tell what's in my bag? Yep. What does it look like? What does it sound like? It's clear. It's a liquid. And I drew a line so you could really see how much. I'm going to let you know this clear liquid is just water. It's just water. I'm going to take these out. I'm going to put these in the middle because 3 pine cones weighed the same as 8 small pine cones. So they balanced. If I were keeping track of this data or information, I would write it down. But mostly I just want you guys to see how it works. So I have some liquid water and I put something else in here. What happens when you put water in the freezer? It changes. Yeah, it changes. It turns into, did you say it? Ice. It freezes into a different form. Ice. I wonder, does water, liquid water, weigh more than frozen water? What do you think? Do you think this bag of liquid water weighs more or less or the same as? Now, I drew lines on here. Do you think that's fair? Are they the same? No, there's more in here. I can see them. It comes over the top. Don't you think they should start out the same? I do too. So I'm going to take some out because I want this to be a fair experiment. So you tell me, does that look right? Let's see. Does that look more fair? I'm going to take out one more. Oh, that looks better. Now they seem the same. Don't those seem the same? What do you think? So if I start out with the same amount, you saw the line in each bag. Do you think they'll weigh the same? Frozen water and liquid water? Let's try it. Hold on, I need to check the bugs. Probably running around my floor right now. Okay, we're starting with an empty balance scale. I'm going to put the frozen water in first. Do you think it's going to weigh more than nothing? Let's try. Whoa, I can tell already. Boy, that just went straight down. Frozen water weighs more than nothing. That's what we found out. Here we go. Do you think it's going to balance the scale? Do you think it's going to weigh more than frozen water? Let's see. Here I go. What did you find out? Tell your grown-up. Which one weighs more? Frozen water or liquid water? I just saw one of the bugs. It's crawling on my floor. Here, I'm going to put it back up here. Come back up here, little bug. Liquid water weighs less. Oh, wait, did I say that wrong? I got distracted by the bug. Let's try it again, just to make sure. Frozen water, liquid water. I had to do it again. And sometimes you have to do your experiment again to make sure that you get the same result. That's always a good experiment. So we found out that it's true because we tried it more than once. That liquid water weighs more than frozen water. I would love for you to be able to try some of these experiments at your house. Do you have a scale? I wonder if we could make a scale so that we could keep practicing which weighs more. I bet you have things at your house that you wonder about and you'd like to compare. That's an idea for another video. I'll have to look around my house and see if I can find some materials and see if I can invent another scale so I can show you maybe how you can make a scale at your house. See you next time.